Can you all see my screen?
Yes.
Okay. So we'll be going through the states of matter. So yeah, since we have students from different grades, what I want to do is I want to start from the very basic and then see where we can go from there. Right. So it is starting from the very basic and we will focus on the conceptual understanding of everything that we have inside states of matter. Right. So within this topic, we'll study how the particles in a matter are arranged for different states, right? For example, if you look at solid, if you look at liquid, you look at gas, the particles. So why are they exhibiting different properties? Because the particles are arranged in different manner, right? So you'll see that. So this lesson I will divide it into two major parts. The first part will discuss about matter and its state. So the different states of matter, that is solid, liquid and gas, we'll study in detail. Then we'll study why do we need to change, or uh, uh, how do the different states of matter change among each other. For example, how do solids change to liquid, liquids change to gas, or gas change to liquid, gas changes to solid, and so on. And then, I mean, we have some changes, so we characterize those changes as physical and chemical changes. Physical changes means changes wherein no new substance is formed. Chemical changes means new substances are formed, right? So we'll discuss everything in today's class. Then we have, if we have time, then we'll go through some questions from previous year papers. Okay. Uh, so to begin with, what is matter? Can anyone tell me what a matter is? Anyone?
Which have mass and take space.
Yeah, very good. So if you look at anything around you, right, and observe it, so it will have some mass and it will occupy space. So to, I mean, for a matter to qualify, or for any substance to qualify as matter, it should satisfy two criteria. The first criteria is it should have mass, and then it should occupy space, right? So if you look at your phone or laptop, right, so it will have some mass because you can feel the mass, and then it also takes some space, say on your desk, on your table, right? So that is why it is a matter. So matter means anything that you have around you, it should have some mass and then it should occupy some space. Okay. So if you look around you, so you are made of matter because you have mass and then you occupy space. Water is made up of matter, right? Balloon and the air inside is also made up of matter, right? uh, is air a matter?
Yes, sir, air is a matter.
Yeah, why is air a matter?
Sir, because it takes up space.
Yeah, but does air have mass? So see, you cannot feel the mass of air when it is, when the amount is very small. But if you take large amount of air, for example, the cylinders that you have in your homes, so it is also made up of air, but the air is compressed, right? So then you can feel the mass. So when you have a large quantity of air, then it will have some mass. Okay, so that is why air is also a matter. Is this clear? So
Yes, sir.
stop me if you have any questions in between, or if anything seems not clear. So we'll go through it. So see, when you look at anything around you, it will be in any of these three states. Apart from that, no other state is possible. We have more states, but we'll go through that in later classes. So, but majority of things around you will either be in solid state or liquid state or gas state, right? Solid, for example, this eraser, it is in the solid state. It means it has a fixed shape and a fixed volume. Liquid means it is in the liquid state, for example water, right? It will have a fixed volume, but it will not have any fixed shape. When I say it does not have any fixed shape, so if you pour this liquid in this container, it will take the shape of the container. If the shape of the container is different, it will take the shape of that specific container. Okay. And then you have gas, right? For example, water vapor, steam, or say air around you. So it does not have any fixed shape and it does not have any fixed volume. So if you store air in any jar, it will take the shape of the jar, and air also does not have any fixed volume. We'll see why in the later classes. So these are because of the particles inside them, right? So see, we have matter, right? Matter is made up of what? Anyone knows what an atom is or what a molecule is?
Smallest unit of
What may I say?
smallest unit of matter called atom.
Yeah, very good. So see, when you have matter, say anything. So say if you have a piece of paper, right? You divide it into two parts. Then you take this part, divide it again into two parts. Then you take this part, divide it into two parts. So you do keep on doing it. Then a very small, tiny part will come wherein you won't be able to divide it further. So that smallest indivisible or tiniest unit of a matter is known as an atom, right? And what is a molecule? So atoms are the smallest unit of any matter. So matter are made up of atoms, but atoms, if you look at atoms, they may or may not be stable. By stable, I mean that, so if you look at any substance around you, so there are substances which may be stable, there are substances which may not be stable. Um, Stable substances means it does not need anyone to react. For example, if you look at iron, right? If you have, for example, gold, right? So if you have gold, right? Gold is a stable metal. We call this as a stable metal because it can stay without the need of anyone. But if you look at hydrogen, right? Hydrogen, say it combines with oxygen to form water, right? So you'll not find hydrogen like this H. So it will either combine with itself to form hydrogen gas, which is H2, or it will combine with oxygen to form water. So this H is an atom, or this iron is an atom, or gold is an atom, but when it combines with itself or any other atom, it is known as a molecule. Okay, so atom means individual unit, molecule means combination of one or more atoms. Okay, so that atom can be of the same kind or different kind. Okay, so any question? Okay, so now see, the atoms or molecules inside solid, right? So the property of solid is that solids have definite shape, it has a fixed shape. So if you have a, say, solid iron rod, it will have a fixed shape, right? And it will also have a fixed volume, right? So you cannot change the volume of solid, or you cannot change the shape of solid, although there are some exceptions. For example, rubber band. So you can change the shape, but then it will regain its original shape, right? But usually it is very hard to change the shape of a solid. Right, so it is very difficult to change the shape of a solid. Why is it very difficult? Because if you look at the particles or the molecules inside solid, so we just discussed that any matter is made up of multiple atoms, right? So if you look at the arrangement of that, so they are arranged very close to each other. So they are very close to each other, and then the pattern is also regular, right? So it is not, so why do solids have a definite shape? Solids have a definite shape because the particles are very close to each other. Okay, and why do solids have a definite volume? They have a definite volume because the particles, they are arranged in a regular pattern, right? So both of this explains why solids have a definite shape and a definite volume. Okay, so when you talk about the arrangement of particles in solid, the first thing is particles are packed very close to each other, and the second thing is they have a regular pattern, right? So this will be clear if you look at liquids and gas. So see, the particles are tightly packed in solid, they are arranged in a specific pattern, and they are bound to each other, right? Or they are, since they are tightly packed, they are not allowed to move, so they can only vibrate, they cannot move from one place to another, right? And because of these arrangements of particles, they have the following properties. Solids are rigid, they have a fixed shape, they have a fixed volume, you cannot compress a solid, and solids cannot flow like liquids, right? There can be some exceptions. For example, if you look at this book, so they are usually not rigid, right? So they can be flexible, you can have flexible books, right? But most of the solids, I'm talking about most of them, so most of them are rigid, right? Then you have examples of solids. So for example, this cup, shirt, book, eraser, these are all examples of solids. Okay, then if you look at liquid, so what is different from liquid? So solids have definite volume and solids have definite shape, but liquids, they do not have definite shape, so their shapes change, right? Why do their shapes change? Because the particles can move, that is why their shape changes, right? So if you have this container, and then if you take a container like this, if you pour water from this container to this container, so the particles will change its shape, or liquid will change its shape like this. So from this to this, it can change its shape. But is it possible with a solid?
No, sir.
No, it is not possible with a solid because they are attached, so they are not allowed to move. The particles of solids are attached to each other by very strong, we call that force of attraction as intermolecular force. So the force of attraction between two molecules is known as intermolecular force of attraction. Since the solid particles are uh, I mean attached to each other by a strong intermolecular force of attraction, that is why they cannot move. And if you pour a solid item from this container to another, it will have the same shape. But in liquid, since they are allowed to move because the force of attraction is very small when compared to solids, that is why they can move freely and then occupy this space, and then they have a fixed shape, right? So if you look at the particle arrangement, so they are close together just like solids, but in case of solid, the particles had a regular pattern like this. In case of liquid, there is no regular pattern. So in solids, the pattern was like this, but in case of liquid, there is no regular pattern, so the particles can flow very easily. Then they have very little free space between them. Solids had almost negligible space, but liquids have slight free space between them. Okay, so that is why they do have a fixed volume. However, they can slide and roll past each other. So the particles, they can slide past each other, right? So you can imagine if you are pouring this into another beaker, so the particles can slide past each other, right? So because of this arrangement of particles, liquid has the following properties. The first thing is not rigid, unlike solid. So if you pass your hands across liquid, right, you will be able to pass your hand freely, right? Although there is some resistance from liquid when compared to air, but you can pass your hands through a liquid, but it is not possible in case of a solid, right? It does not have a fixed shape. So if you change the beaker or if you change the container, the shape of liquids change. It does have a fixed volume. For example, if you have 1 liter of oil in a container, you pour it to another container. Will the volume increase or decrease? It will remain the same, right? So that is why it has a fixed volume. So you can slightly compress, you cannot fully compress a liquid, you can only slightly compress a liquid. This is because the particles are close together, right? So that is why it is not possible to fully compress. And then the liquid particles can flow, right? That is why, I mean, since the particles can slide and roll past one another, so that is why liquids are able to flow. Any doubts, anyone?
No, sir.
Okay, so then you have examples of liquids.
No, sir.
Okay, fine. So then maple syrup, which is used in donuts, pancakes. Then you have shampoo, olive oil, orange juice. So all of these, they have a fixed volume, right? So if you pour the shampoo from one container to another, the volume is not going to change. It is, say, if the shampoo is of 400 ml or say 1 liter, if you pour it to another container, it will have the same volume. So that is why liquids have fixed volume. But if the shape of container is different, say if you pour the shampoo into this glass, so it will take the shape of this glass. So that is why we say it does not have a fixed shape. Then you come to gas. So gas is different from solids and liquids. Solid has had a fixed shape and a fixed volume. Liquids had a fixed volume but no fixed shape. Gas does not have either fixed volume or shape. So the volume of gas is not fixed and the shape is also not fixed. Why is this so? Because the particles are very wide away from each other and they constantly move, right, at very high speeds. So how are the particles in gas arranged? The first thing is they are widely spaced. The space is very much more wider when compared to liquid. So for solid, the space was very small. For liquid, it was slightly larger than solid, and for liquid gases, it is very wide. Okay, so distance between two molecules is very far apart. Then they travel in straight lines, so they'll keep traveling, keep moving like this, right? So particles keep moving like this until and unless, so since there are a lot of particles and all particles are moving, they do collide with each other, right? Or say they can collide with the surface of the container wherein you store it. So if this is moving, so it can collide and then it can bounce back. It can collide with this and then it can rebound. So that is what it is saying. So they travel in straight lines until they bounce off another particle or surface and they move around very quickly. So this particle arrangement results in the following properties. The first property is it is not rigid. Again, you can pass your hands very freely across air, right? Slightly less freely across water, but still you can pass your hands. But from across solids, you cannot pass your hand. So that is why solids are very rigid. It does not have any fixed shape. It does not have any fixed volume. Can anyone say why gases how gases have no fixed volume?
Sir, because their interparticular space are very wide.
Yeah. So the spaces between the particles are very wide and they are free to move, right? So say if you have a jar like this, or if you take a glass like this, okay? So, and then take anything, for example, incense stick, right? That releases smoke, right? If you store it in this jar, then you remove the lid of the jar and then bring in another container like this. So this smoke is also a form of gas, right? Smoke is a matter because it has mass and it occupies space. And then what state of matter it is? It is gaseous state of matter. And if you remove this lid, what you will see? Gases, the smoke will occupy this space as well. So initially the volume was this much only, the volume of this glass, but if you remove this, the volume increased, right? So that is why we say it does not have any fixed volume. Okay, shape, it is free to take any shape which you put in. Then you can compress gas, right? So one of the application of compressed gas is what we use in our homes, which is LPG. So LPG means liquefied petroleum gas. So it is a gas which you compress and make it in the form of liquid. So if you compress gas, it becomes liquid. Also, if you have CNG vehicles, right? So they also use compressed natural gas. So this is a natural gas, or it is a state of matter which is gaseous, then you compress it. So this property of gas which allows it to be compressed has many real life applications. Okay, and then gases can flow as well. Okay, so examples of gases: helium in a balloon. So you have seen helium balloons that float in air, right? So the helium gas inside this balloon is an example of gas. Then you see steam coming out from a kettle. So this steam is an example of gas. Then you have argon in a tank and nitrogen in a tank. So these gases are stored in tanks like these, right, at a specified temperature and pressure. Because if you change that, if the pressure and temperature changes or fluctuates even a bit, then this gases can escape or their properties may change, right? So you have to store them in a controlled environment. Okay, any doubt? Okay, no questions, I believe. Uh, then, I have two questions. So, can you stir a solid? Just like we stir a liquid, right? Can we do that with solid?
No,
Why?
no, sir.
Why? Why it is?
Sir, because when we stir a liquid, the space.
Because it is closely packed and it.
Yeah, it is closely packed and the particles are not allowed to flow, right? In a solid, they are only allowed to vibrate, right? So, if you look at the structure of solid, so whenever you get a question on can you do this with a solid, can you do this with a liquid, can you do this with a gas, so you have to look at how the particles of solid or liquid or gas are arranged. The first thing, so the question is saying can you stir a solid. Now you will see how the particles are arranged. So the particles are arranged, first of all, they are held very close to each other, very tightly packed, and they have a fixed pattern, right? And they cannot flow, they cannot move, they can only vibrate. So when you are stirring a solid, what you want to do, you want to or put your spoon say around here, right? So you want to separate these particles when you want to stir a solid, right? So which is not possible because they are held very close to each other. That is why you cannot stir a solid. When I ask can you stir a liquid, it is possible because liquid particles, they don't have any regular pattern and they can flow against each other. So if you put a spoon like this here, so the particles can move, right? They are free to move. So that is why you can stir. Although there can be, so see, there are different types of liquids. If you take a very thick liquid, you'll experience some resistance while stirring. So those liquids, that is because although liquids are allowed to flow, still the particles are very close to each other. So that is why you will have some resistance. But if you look at a gas and if you try to stir, there is almost negligible resistance because if you look at the particles of gas, they are very widely spaced. So say one particle is here, the another particle can be here, the another particle can be here and here. So it is very easy to stir a gas, right? Relatively easier for a liquid and very difficult for a solid. Okay. Now, can you hold a gas?
No, sir.
Why?
No, sir.
Because the atoms are very packed and very far away.
Yeah, so they keep on moving, right? So if you have a container like this which is open, right, and if you uh, if you store a gas inside this container, right, the particles of the gas continuously move, right, in random directions. So it will very quickly escape this container if you keep this lid open, right? Say you may have seen smoke, right? So in a room, smoke escapes very quickly, right? It spreads in all directions. So why is it? It is because the particles, first of all, the particles of gases are very widely spaced, Second, they constantly move in random directions, right? So they will keep on moving, and this movement causes them to escape. So that is why it is very difficult for you to hold a gas. Okay. It is also slightly difficult for you to hold a liquid because the particles are free to flow, right? But solids you can hold because the particles are not allowed to move in a solid. Okay, so I mean, can you tell me which of the following is a solid, liquid, or gas? For example, this tree, is it a solid, liquid, or a gas?
It's solid.
Yeah, it is a solid. This drink coming out from this can,
Liquid.
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 Water,
Liquid.
It's a liquid.
yeah. This box,
Solid.
yeah.
Solid.
What about this? So this is a blower. Air is coming out of this blower.
Gas.
It's a gas.
Yeah, it is a gas. What about this stapler?
It's a
Gas.
solid.
Liquid.
Yeah, very
Solid.
good.
Solid.
What about this container carrying a juice? So
Liquid.
liquid.
Solid.
Container is solid. Very good. Juice inside this is a liquid, right? Then this board,
It's a solid.
Solid.
yeah, it is a solid. This book,
Solid.
Solid.
yeah. If anyone is not able to follow, you can stop me and ask if you have any questions. Okay. Now this is a question you have to guess the state. So there, Anant, he found a mystery substance with the following properties. The first property is it follows the shape of its container. Okay. The second property is it flows. Third property is it has a fixed volume. Fourth property is it can be slightly compressed. What is it?
It's a liquid.
Yeah, it is a liquid, right? And then draw the arrangement of the molecules Anant found here. So you have to draw the arrangement of molecules inside a liquid, right? So to draw the arrangement of molecules, what you can do if you are asked to draw the arrangement of molecules in a solid, so you have to draw regular patterns like this. Okay, ensuring the space is small across them. So this is how the arrangement in solids look like. Liquids, you can again ensure the space is small, but the pattern is random, like this. So you can draw random patterns with small spaces around them. And then if you are asked about gases, so what you can do, you can show this or use this arrow to show that they are moving very rapidly, and then they have wide spaces between them. Okay. Now see, it says it follows the shape of its container. When it follows the shape of its container, that means it does not have a fixed shape, right? So shape is not fixed, which means it can be a liquid or a gas, right? Then it says it flows. You know, liquid and gas can flow. So again, from here also you can say it can be a liquid or a gas. Now this gives you the hint that it is not a gas, it is a volume. It is a liquid, because liquids have a fixed volume, gases do not have a fixed volume. So from here you can say this point is the most important point, which gives you the hint that it is a liquid and not a gas. Okay. So yeah, I mean, this is a quick recap. So solids particles are very tightly packed and arranged in a regular structure. So these two are very important. Particles are tightly packed and arranged in a regular structure. They also vibrate. So they are not allowed to flow, but they vibrate. Examples are book and lunchbox. Liquid particles are not arranged in a regular pattern. So pattern is not regular, but the space is small. Right? So this is similarity between solid and liquid. So the particles have very small space between them, and this is the difference between solid and liquid. So pattern is not regular. Okay, and they slide. So because of this irregular pattern, they can slide and roll past one another. For example, water and juice. Then gases. Gases is very different from solid and liquid, some similarity between liquid and gas because both of them can flow. So particles are widely spaced and fill the space they are in, and they move around very quickly. For example, wind and steam, right? So here in the previous question, I guess this was wind. So if we talk about this tree is a solid, this wind is a gas, right? Which is an air. So that is why it is a gas. Now see, so when you have this kettle, right? You may have seen steam coming out of a kettle or any container which is very hot, right? But that container has liquid inside it. It does not have any gas inside it, right? Say if you take water in a kettle and then heat that water, you will see steam coming out from that. Why is it happening?
Sir, because the water is evaporating.
Yeah, water is actually boiling, and what is actually happening there? Why is it boiling? Or why do you see this steam? Can someone answer in terms of the particles that we were discussing about?
Sir, because when liquids are heated, the space between them expand and they become a gas.
Yeah, very good. So, see, you have liquid particles. You know, liquid particles are closely packed, but they are allowed to flow, right? When you pass on heat, what this heat does is it provides energy to these particles, right? This energy allows the particle to move, right? Via kinetic energy. Kinetic energy is the energy possessed by a body in motion, right? So this allows the body to move because of the energy it got from the heat. And once it moves, what happens? The spaces between the molecules starts to increase, and then it becomes gas, right? So by providing energy, you ensure that the spaces between particles are more, and then it has changed state from liquid to gas, right? So say this is a typical phenomena known as change of state, right? So this is known as change in state. So you have solid, you have liquid, and you have gas, right? So change in state means solid can be converted to liquid, liquid can be converted to gas, and gas can be converted to liquid, and so on, right? So any one change in state, any one state can be converted to another state by the application of heat, right? So there is one more thing, by application of pressure as well, but it is not in your syllabus currently. So we'll just limit it to heat. So if you say provide heat, or say if you heat it, or say cool down, you can change states of matter, right? So you can change solid to liquid or liquid to solid. You can change liquid to gas or gas to liquid. Even you can change, for some substances, you can change solid to gas and then gas to solid. Okay. So this is known as change in state, right? So when you are changing, say, solid to liquid, or the first thing that you should know about change in state is it is reversible. So understanding this through water is very easy. So you have ice, right? Ice is solid, right? And then you have water. Water is liquid. And then you have steam. Steam is gas, right? So change of state means converting ice to water. How can you convert ice to water?
By boiling or heating.
Yeah, by heating you can convert ice to water, because if you boil, you'll get water to steam, right? So if you heat ice, you'll get water. Now, can you get water from, ice from water? If you freeze water, you get ice, right? So this means change of state is reversible. Reversible means you can reverse this. So if I change ice to water, I can get back ice from water, right? Or I can change back water to ice. So this is the meaning of reversible, something that can be reversed, right? Then it means it does not involve temperature changes. So when you are changing state, temperature is not changing. So say for example so what is the freezing point of water? Freezing point of water?
0 degree Celsius.
Yeah, very good.
0 degree Celsius.
So freezing point of water means the temperature at which water becomes ice, right? Which is 0 degrees Celsius. So this is fixed. So temperature is not changing when water is freezing. Okay? Or say boiling point of water. Boiling point of water is, what is the boiling point of water?
100 degrees
100
Celsius.
degrees Celsius.
Yeah, 100 degrees Celsius. That means exactly at 100 degrees Celsius water is going to boil, right? So there is temperature will not change when water is boiling. So when this is very important, that when there is change of state, temperature is not changing. Okay? Then it is a physical change. We'll discuss about physical change later, but physical changes are changes which can be reversed and in which new substances are not formed. So here you can see this change can be reversed, right? And it remains the same thing, ice and water. So their constituent is the same, H2O. So that is why it is a physical change. And then change of state occurs when heat is removed or added. So if you want to convert solid to liquid, you add heat. If you want to convert liquid to solid, you remove heat or you freeze it. Okay? So this is all about change of state. Then you have different types of change of state. So first type is melting. So if you have a solid, right, you want to convert it to liquid. When a solid changes to liquid, it is known as melting. So let me just write. So this is solid, this is liquid, and this is gas. Okay, so when a solid changes to liquid, so when you are converting solid to liquid, this is known as melting, right? And when you are converting liquid to solid, this is known as freezing, right? So melting is the process wherein you convert solid to liquid. For example, if you have ice, you can melt it to form liquid. If you have butter, so if you have a block of butter, if you heat it, it gets melted to form a liquid butter, right? So you have to add heat while melting something, right? So when converting from solid to liquid, you have to apply heat or provide heat, right? And if you do the opposite, so you'll convert liquid to solid, you have to freeze it or remove the heat, right? So freezing or cooling means removing heat, or melting means adding heat, right? So when you freeze, liquid changes into a solid. So freezing is the process wherein liquid changes into solid. For example, water turning into ice. Or say if you have this liquid butter, if you freeze it again, it will become solid butter. So that is again an example of freezing. Okay, so this is an exception. So this is a metal that melts in your hand. So gallium, so it will be solid at room temperature. So gallium is a metal. So if you have iron, iron is also a metal, right? So just like iron, this will be solid at room temperature. Room temperature, I mean 25 degrees Celsius. Okay. So now if you keep iron in your hand, will it melt?
No, sir.
No, iron is not going to melt. But if you keep this metal in your hand, it is going to melt. Right? Why does this happen? Because this metal, it has a very low melting point. Melting point means the temperature at which something melts. Right? So this melting, so if you want to melt ice to water, right? So what is the melting point of ice? Anyone? Freezing point of water was
0 degree Celsius.
0 degrees Celsius. So same is the melting point of ice. Okay, so see what is happening if you freeze or if you reduce the temperature to 0 degree. So what is the room temperature? Room temperature means something around 25 degrees Celsius. So it is the temperature of our room, right? So if you reduce the temperature to 0 degrees Celsius, water in your room will change to ice. Okay, but if you are living in, say, Antarctica, which has temperature in negative, say minus 10, minus 20 degrees Celsius, right? There you won't have water, you'll have ice. And then to get water, you have to increase the temperature. Now, if you increase the temperature from minus 10 to say 0 degrees Celsius, you'll get water. So here, what is happening? You are increasing temperature to 0 degree. Here, you are decreasing temperature to 0 degree. So 0 degree Celsius is the melting point of ice, and 0 degree Celsius is also the freezing point of water. So the melting point of ice and freezing point of water is the same. Okay, any question?
No, sir.
No, sir.
Okay, so melting point is the temperature at which a solid melts to liquid, and freezing point is the temperature at which a liquid changes to solid. So gallium has a melting point of 29.8 degrees Celsius. But if you put it in your hand, what is the temperature of your hand? What is the body temperature of human being? Normal body temperature.
30 degrees Celsius.
So it will be around 37, 36 to 37 degrees Celsius. Okay, so this is the normal body temperature. Now this is much higher than the melting point of gallium. So if you keep it in your room is at 25 degrees Celsius, which is below the melting point. Right, so at 29.8 degrees Celsius it is going to melt, but your room temperature is only 25, so it will not melt when it is kept in open air, right, inside your room. But if you keep it in your hand, the temperature of your hand is 37 degrees Celsius, which is much higher than the melting point of this substance. That is why it melts in your hand. So this is a metal that melts in your hand. Okay, so you can remember this as an exception. And then you have another types of changes of state. The first is evaporation. What is evaporation?
Sir, when water changes to vapor.
Yeah, when water changes to vapor. And condensation means when vapor changes to water, right? So when we talk about evaporation and condensation, it is not only limited to water, it is limited to, I mean, you have to generalize it to liquids, right? So because not only water undergoes evaporation, other liquids may also undergo evaporation. Although water is the most common substance that we see evaporating, but there can be other substances as well. Okay, for example, the liquid that is used in our ACs, that is R134A. So this is a type of liquid that also evaporates and condenses. So it is specific, I mean, liquids can evaporate. Not only water, but liquids can evaporate. So evaporation is not only applicable to water, it is applicable to all liquids. So evaporation is the process wherein liquids changes into gas, and to evaporate you have to provide heat, right? Again, you have liquid to gas. So when you are converting liquid to gas, you should add heat, right? And when you are converting gas to liquid, you should remove heat, right? So you should cool a gas to get a liquid, and you should heat a liquid to get a gas. So heating means add heat, cooling means remove heat, right? So example of evaporation is wet clothes drying in the sun, and example of condensation is formation of cloud. Okay, now when we have evaporation, we have boiling as well. What is the difference between these two? Or are these the same thing?
Sir, they are the same thing.
Okay, so say what is the boiling point of water? 100 degree.
100 degrees Celsius.
Yeah, so it is 100 degrees Celsius, right? So that means if they are the same thing, say evaporation means, say your clothes are drying in the sun, so it is an example of evaporation, right? So is the temperature of your cloth equal to 100 degrees when they are drying in the sun?
No, sir.
No, right? So that means these two are different things. Evaporation, boiling point, water boils at 100 degrees Celsius only. It does not boil below it. But evaporation can occur at any temperature. Right? You may ask why evaporation, why water is converting to gas at any temperature. So see, when you have, say, you have a cloth that is drying in the sun. So it has some molecules that is exposed outside. As I mentioned, liquids are free to move, right? So they are free to move. So what happens? Only liquids that are at the surface, they get some energy from the sun and they escape the surface. Only liquids that are at the surface. The liquids that are inside the shirt, they will not escape. Okay, so liquids that are at the top, it only escapes because of the heat from the sun, which may be lower than 100 degrees Celsius, say which may be say 45 degrees Celsius only. So evaporation can happen at any temperature. So you may have noticed that, say, if you keep your cloth drying using a fan as well, so it can dry, although it will take some time, it dries off, right? So evaporation happens also inside your room. So it is just the vapor. Now why does that happen? Because the fan, right? So it again provides energy to the molecules that is at the top to move, right? So that is what evaporation is. But boiling, what is boiling? So it will only happen at 100 degrees Celsius at a specific temperature. So you have water, then you provide heat to this water. Now because of this heat, molecules not only at the surface but inside the water will get some energy, and then they will reach the surface because of this energy and then escape. So this is boiling and this is evaporation. Okay, evaporation is a slow process because you have to leave your clothes to dry in the morning and then collect them in the evening, whereas boiling is very quick, right? So if you let water boil for say 10 minutes, it will boil, but evaporation, it takes a long time, right? So that is why evaporation is a slow process, whereas boiling is a fast process. And another difference is evaporation can occur at any temperature, boiling only happens at 100 degrees Celsius. That is why these are different. Okay, any question?
No, sir.
Okay, then we discuss changing solid to liquid, liquid to solid, and we also discuss changing liquid to gas and gas to liquid. So there is one more thing. You have solid, without conversion to liquid, it can get converted to gas, right? So direct conversion of solid to gas. So this is known as sublimation. And direct conversion of gas to solid, this is known as deposition, right? So there are only few selective materials or matter for which this is applicable. For example, camphor or kapoor that we have in our home, right? That is used in puja. So if you burn that, it will not get converted to liquid. It will directly change to gas. Has anyone noticed it? Or has anyone seen this thing? This is camphor,
Yes, sir.
right? So if you burn this, you'll not see any liquid state. So it will directly change to vapor. So you'll just see vapor of this coming out, right? So this undergoes direct change in state from solid to gas. There is no intermediate liquid that happens. So see, for example, if you heat ice, it will first get converted to liquid, then it will change to steam. But if you use this camphor, without even getting converted to liquid, it will directly change to gas. Okay, so this process wherein solid changes directly into gas is known as sublimation, and then you have to add heat for the process of sublimation. So dry ice is also an example. So dry ice, is there has anyone seen this dry ice? So if you order ice cream, right, say a container of ice cream, only a few selected brands will give you a container that has dry ice and then store ice cream inside it, right? So if you are transporting anything from one place to another in ships, right, so something that is very cold, if you want to store that or transport that from one place to another, you use dry ice for the sake of transportation. So dry ice is something that is in the solid state, and if you expose it to the atmospheric temperature, or say 25 degrees Celsius, it will directly convert to gas. It will not get converted to liquid. So this is another example, but this is the most common one that we see in our daily life. Okay. Then deposition is usually seen in areas wherein the climate is very cold, right? So say in regions like US, if you wake up early in the morning, you'll see frost collected inside on leaves, right? So in hot and humid climate like India, we'll see dews, right? Is in grasses, right? Small droplets. But in climates like US, wherein the temperature is very low, you'll see such frost occurring in leaves. So these are basically, or even on windows, you'll see these frost. Okay. So this is an example. So this is an example wherein gas is directly converted to a solid, which is known as deposition. Okay. So frost is an example of deposition, right? So what happens in frost? You have water vapor from the atmosphere or air in the atmosphere. Because of the extreme cold temperature, it does not get converted to liquid, it directly gets converted to solid state or ice. Okay, so this is deposition. Any doubts? Any question?
No, sir.
Okay. Right. So again, a quick revisit. Change of state occurs when matter changes from one state to another. Then you have different types of changes of state. Freezing. So freezing means converting. What is the process of freezing? Anyone? Freezing means to convert what to what? Solid to liquid, liquid to gas, or solid to gas?
Sir, solid to liquid.
Solid to liquid would be melting. Freezing means, like say,
Liquid to solid, sir.
yeah,
Okay, sir.
right?
Liquid to solid.
Yeah. Freezing means liquid to solid. What about melting?
Solid to liquid.
Solid to liquid.
Yeah. What about evaporation?
Liquid to gas.
Yeah, liquid to gas.
Liquid to gas.
Very good. What about condensation?
Gas to liquid.
Yeah.
Liquid.
What about sublimation?
Liquid to gas. No, solid to gas.
Yeah,
Solid
solid
to
to
gas.
gas. So there is no liquid in sublimation. And what about deposition?
Gas to solid.
Yeah, very good.
Gas to solid.
Yeah. So you are directly converting gas to solid in the process of deposition. For example, frost. Okay. Now we have already discussed this. What is a melting point? What is freezing point? What is boiling point? So if you consider water, melting point is the melting point of a substance is the temperature at which it changes from solid to liquid. Okay. So for water, 0 degrees Celsius is the melting point. Freezing point of a substance is the temperature at which it changes from liquid to solid. Right? Again, it is 0 degrees Celsius. Again, remember that melting point of water is 0 degrees Celsius. Right? Sorry, melting point of ice is 0 degrees Celsius. And freezing point of water is 0 degrees Celsius. Right, so here I am not saying melting point of water is 0 degrees Celsius, because why do I need to melt water? I need to melt ice, right? So I need to heat ice at 0 degree to get water, and I need to freeze water at 0 degree or to 0 degree to get ice. So that is why I say freezing point of water is 0 degree, because I have to freeze water, and I say melting point of ice is 0 degree because I need to melt ice. And boiling point of a substance is the temperature at which it changes from liquid to gas. So this is boiling point, which is 100 degrees Celsius. So boiling point of water is 100 degree because we are boiling water to get gas or water vapor, right? Now, can anyone tell me what is the most interesting property of water that they have observed so far?
Melting.
Okay. Anyone else?
Not a rigid, not a rigid,
Okay.
no fixed shape,
Yeah, water does not have any fixed shape.
fixed volume,
Yeah, water has a fixed volume.
can be compressed,
Yeah, it can be slightly compressed.
can flow.
Yeah, very good. So see, if I have to say what is the most interesting property of water for me, so see, water is the only substance for me which I can see in all three states, right? So I can see ice, I can see liquid, I can see steam, right, in our day-to-day life, right? So water is one of the most important substances in our life, and it is also very interesting because it can exist in all three states, right? Another important property, maybe I can give you an example. So you all know about cold drinks, right? All of you must have consumed cold drinks. So whenever you purchase cold drink, so is that cold drink, I mean, is that bottle of cold drink completely filled, or is there some gap, empty space? So if you purchase, say, a bottle of Sprite or say Coca-Cola, right? So if you take that bottle, if you purchase that bottle, will it be completely filled, or is there some gap there?
Is there that?
Yeah, so there will be some small gap, right? Wherein you'll not see any cold drink. So it will be vacant. This gap will be vacant, right? And then you'll only have cold drink till here, right? Right, maybe I can show you an example. Yeah, see, for example, this bottle or this bottle. So it is only filled till here, right? It is not completely filled, right? Or any can or anything, any bottle you purchase for cold drinks, it is, or any water bottle container, it will not be filled completely. Anything that you are storing in fridge. Why is it so? Is my question clear?
The atoms of the liquid or juicy packed can move.
Yeah, they can move. See, what happens is that, so two, I mean, cold drinks are always stored in fridge, right, at temperature in the range of 0 degrees Celsius to 4 degrees Celsius, right? So they are always stored in fridge, be it cold drink or say water, whatever, right? So you store it in fridge. So there is one property, say if you are heating something, right? So if you heat something, will it expand or will it contract? Expand means volume increases, contract means volume decreases. So if you heat something, say if you are heating ice, does it expand or does it contract?
Expand.
Yeah, it expands, right? Here you are freezing ice, right? So ideally it should contract, but what happens is that, so see, the general idea is that if you heat anything, it should expand. If you cool anything, it should contract, right? But water has this interesting property. So that is why I said interesting property. So water has this interesting property wherein if you heat it only in this range, right? If you heat it in this range, ideally it should have expanded, but it contracts. And if you cool it, it will expand. So this is known as anomalous expansion. Okay? Anomalous means this is an odd behavior which you don't expect, right? So this is known as anomalous expansion. So this is a property only specific to water. Now see, if you are cooling it, if you are freezing it, ideally it should have contracted, but because of this anomalous expansion, it expands. Rather than contracting when freezing, it expands. So if you fill it, if you completely fill it and if it expands, the water bottle will burst. Right, so that is why you don't fill it completely, you provide a bit space so that if you cool down or if you freeze it, it has some space to expand. Otherwise, the water bottle is going to burst. Okay, and then you may have seen cases like this wherein you have ice at the top and water at the bottom. Has anyone seen this?
Yes, sir.
Right.
Yes, sir.
So see, you,
Sir, in cartoon.
yeah, right. So this is actually this is something that happens in real life, and if this did not happen, then what would have happened is that fishes inside would not be able to survive. So can fish survive inside ice? No, right? They need water to survive, and this anomalous expansion of water is responsible for sustaining life or aquatic life, because what happens is that when you have ice, it stays at the top, right, because it has lower density, and water, it stays at the bottom, right? So we'll discuss about this more in more detail, but for now just remember that this anomalous expansion, right, I already explained one simple example using this cold drink, and this is also responsible for this wherein you see this ice at the top and water at the bottom. This is only possible because of this interesting property of water, right? And if water did not have this property, then fish or any aquatic life would not be able to survive in cold climates, right? So water creates a layer of ice at the top, and then water stays in the bottom, right? So that fish or any aquatic animal are able to survive on earth, right? So yeah, we'll come back to this again later, but for now, I mean, we'll stop at this point. And then we have changes in matter. uh, I mean, yeah, depends on you. If you want me to cover this as well, I can cover, or if you want me to end this session, maybe we can have it in the next class. Let me know what you want. Shall we continue or can we stop for today?
So next class.
Okay, fine. So maybe we'll start this changes in matter in the next class. Okay. Fine, then if you have any questions, feel free to reach out later as well. Okay, then I'm stopping this session. Thank you.
Thank you, sir.
Thank you, sir, for teaching us.
Yeah, thank you.